Hello guys, welcome to STAAD Pro Tutorial, and today I will discuss how to design and analyze earthquake load on RCC building. So first of all, in case you don't have subscribed my channel, please subscribe this button and subscribe my channel, because this channel has been provide a STAAD Pro Tutorial as well as various type of videos which is important for you. So click subscribe button and subscribe. So coming to tutorial, so initially you have to go STAAD Pro and then go to new project and then click space and then give some name and meter and kilometer and next and add beam and then finished. And we have to draw RCC building. So click geometry and run structure wizard and then model type frame model and click frame and length will be 20. Okay, spacing will be 5, height will be 3 default height, and spacing will be 1 and width 20, spacing 5, and then apply. This is the structure and it will be transferred in STAAD Pro. So click transfer mode and then yes and then OK, and we have to assign properties. So click general and then click define properties. Okay, so click rectangle 0.45 and 0.3 as per your requirement, and then click add and then close. Then select here and select enter the structure, click here and control 1 and then assign to selected view and then click assign and then yes. Okay, you can show 3D rendering mode. This is the structure. Okay, and then we have to install building. So select on enter the all structure and then click geometry and then transition and repeat and then y direction step will be 10 and default spacing is 3 and then okay. You can check 3D rendering. This is the model, RCC model. Okay, and then next we have to assign support. So click support and create support, create and pin support and then add and then front view and then select node, bottom node. Okay, and then assign to selected node and then select support, select support and then assign the selected node. Okay, bottom node and then assign selected node and then assign and then yes. Okay, and then we have to provide load. So click load and definition and then click definition. We have to provide seismic load, that is earthquake load. Click here and then click add and then click your code. As for me IS 893 2002. Okay, and then click generate and then city or zone. So I'm click city. Okay, and then click Kolkata as for me. And then special RC movement resting. Okay, and then click important building and then rock or soil type is soft soil. Okay, structure frame, RCC frame building. Okay, damping ratio is 0.05, and then click generate, and then add self void factor, add 1, so add, and then click close, then click load case details, and then add, and then add quick load in X positive direction, click here and copy it, and loading type will be seismic. Okay, and then add. Next load is add quick load in X negative direction, click here, X negative direction, seismic load, loading type, and then click add. And next load is add quick load in Z positive direction, loading type will be seismic, and then click add. And next load is add quick load in Z negative direction, click here, and negative direction seismic load, and then add. And then last dead load, loading type will be dead, and then add. And last load is live load, loading type will be live, and then click add, and then close, and select add quick load in X positive direction, and then click add, and then seismic load X direction factor 1, and then add, and close. Add quick load in X negative direction, click add, in seismic load, and factor X direction factor is negative, so factor -1, then click add, and then close. And the next is add quick load in Z positive direction, so click here and then add, and then click seismic load and Z direction factor is 1, and then click add, and then close. Next load is add quick load in Z negative direction, click add, and seismic load factor will be -1, and Z direction -1, and then click add, and then close. And next load is dead load, click here and add, and dead load self void is -1, then add. Member load is -6 kN per meter, global direction, add. And flow load is -4 kN per meter square, global direction, and range is 3 to 33, and then add, and then close. Last load is live load, so live load, click here and then click add. This is only flow load, so click flow load, and flow load is -2 kN per meter square, range is 3 to 33, and then click add, and then close. So we have to assign this load, so click self void and select the entire structure, and then click assign to selected beam outlet, and then click assign, and then yes. Okay, and wall load. Okay, this is wall load, so click here and click select, and beam parallel to X direction, and select beam parallel to Z direction. You can see isometric view also. Okay, and then click select beam, assign to selected beam, and then click assign, and then yes. And next we have to create load combination. So click load case details and then click add, and then define combination, and then combination is 1.5 dead load plus live load plus wing load, sorry, earthquake load. Okay, dead load plus live load plus earthquake load in x positive direction. Copy it for the next time. Copy, and factor is 1.5 and click dead load, live load and x positive direction earthquake load. Click here and then click add. Next is 1.5 dead load plus live load minus earthquake load in x negative direction. Factor will be 1.5 and click dead load and live load and click here, and earthquake load in x negative direction, so click here minus 1.5 factor and then click here and then add. And next combination is 1.2 dead load plus live load plus earthquake load in z positive direction. Copy it for the next time, and factor will be 1.2. So click dead load, live load and z positive and earthquake load and click here. Okay, and then add. And next last combination is 1.2 factor dead load plus live load minus earthquake load in z negative direction. So click 1.2 factor dead load plus live load, click here, and z negative 1.5 factor to minus and click here and then click add. So combination is ready. So finally we have to design it. So click design and click concrete and choose your code. As for me, IS456. So click IS456 and we have to some parameter. So click define parameter and AFC, that is compressive strength concrete, is 30,000 okay for M30, and then click add. And then reinforcement, main reinforcement, okay, for AP 415 000, and then click add. And then secondary reinforcement for AP 415 000, and then click add. And then ratio will be 3%, then click add, and then close, and then click command, then click design beam, and then click add. And next design column, and then click add, and then close, sorry, command, click, and then click take off, and then click add, and then close. So we have to assign this type of properties. So click compressive strength and enter the all structure, assign. So click assign, and then yield strength. So click here and enter the all structure, select and assign that, yes. And secondary reinforcement, click here and enter the all structure and assign that. And ratio, click here and select all structure and assign to select it. And then beam, stop here, and beam will be Z direction and X direction. So click select and beam parallel to X direction. Then next select beam parallel to Z direction, and then assign to selected beam, and then click assign, and then yes. Next is column. Column will be Y direction. So click select beam parallel to Y direction, and then select assign, and then yes, and then go to analysis and print, and then add, and then close. Then go to analyze and click run analysis, then click here, then click save, and then wait. It will maintain several times. Just wait, and go to post processing mode, and done, and then click here, and then you can check your load. You can check different type of load here. Okay, and you can check shear force, bending moment, axial force, etc. So click here for bending moment. Okay, this is the bending moment in Z direction, this is Y direction, and you can check shear force Z direction, and you can check Y direction in shear force. You can also check axial forces. Okay, you can check every type of load. Okay, every type of loaded, and load combination also you can check. Okay, and you can check your reaction, and you can get report. So click report and output, and your requirement you need to beam and forces, my requirement, and beam maximum moment, beam shear force, maximum shear force, axial forces, and then click here load case. You can selected load is all. Okay, and then okay, this is my report. You can export in MS Office package. Okay, MS Excel or Word. So click file and export it. Click file, export report, and MS Office file, MS Word file. Okay, and then give some name, and then save, and then open. You can check Word file. This is my printing. Okay, so this is the end of the session. Next session will be start how to design RCC buildings subjected to different slab. Okay, so thanks for watching. If you have any problem in this tutorial, please comment and please subscribe my channel. Thanks for watching.